All right, I just want you again to be exposed to these special factor forms so you're aware of it. The first is the difference of squares. And this is kind of the reverse process of the expanding the special product forms that we talked about. If you are given a set of terms in which it's one perfect squared minus another perfect squared, this has a special factor form, a pattern for factoring. And it's just you take the bases that are being squared, so a and b, and you take the sum of those times the difference of those, and that would be the factors of your difference of squares. So just very basically, an x squared minus 25. Rather than go through the trouble of typing the factor into your calculator, so the algebra tab, number 2, hit factor, type in your x squared minus 25, close it off, and hit enter. You could just use this pattern. Right? And the pattern is you have a perfect square. Here's the base of x being squared. Minus 25 is what number squared?
5.
And so if you look at this, it fits this pattern, so you can factor it into the sum and difference of those terms. So the terms are x and 5. Take the sum of them, the difference of them, and that gives you your factors. If you recognize this pattern, you can solve a lot of problems a little bit more quickly than if you actually entered it on your calculator. Now, if you choose to enter it on your calculator to be safe or to verify it, or just that's what you're comfortable doing, you'll still be fine. And the one thing to keep in mind, though, is if you're doing this, just be careful, and I would strongly encourage you to write down the bases that are being squared first. So when you look at this number, 4x squared, is this a perfect square? Is it some number being squared? What number do you square to get the 4? 2. And the x squared, you square x. And then what number do you square to get 49? So here are your two terms. So when you split this into its factors, the terms are 2x and 7, the sum of them times the difference of them. And so those are your factors. And so this special factor form is the one that actually is very useful for you. There's a second special factor form that is a perfect square trinomial is what it's called. It fits the pattern of what we did as the binomial square. Hey, this one is less, this one takes a little more effort to memorize or to plan it. It's still, you're able to do it without a calculator pretty easily, and in 2 more years you'll probably be expected to do that, possibly next year, but in 2 more years for sure. And that is when you have this pattern where, I'll take an example here of, if you have a pattern of 3 terms, where the first and the last term are perfect squares. So again, you look to see what's being squared here and what's being squared here. And then if the middle term happens to be twice the product of this, so if you take the product of this first base and this last base and then you double it, do you get this middle term? Your bases are x and 3. The sign in between is your negative, and so that would be the factors. This fits the pattern of a plus b, that's this binomial square. In these problems, again, this one isn't quite as easy to see, and it's not necessarily as much a time saver as the other one is. And so if you're given a problem where you're asked to identify the factors, so 9y squared plus 12y plus 4, if you wanted to factor this, it may, in fact, be easier to use your calculator. Hit F2, the algebra tab, number 2 factor. Type in the expression exactly as it appears, 9y squared plus 12y plus 4. Close it off, hit enter. And it shows you that binomial square form, which is 3y plus 2, quantity squared. Okay. Now, if you do use letters other than what's written in the problem itself, do make sure that you double check it and convert them back into the normal letters. Here, y's are used. You can use any of the letters that you have by using the alpha key as well. If you were doing this by hand, just again really quickly, look to see what base do you square to get the first term, a 3y, and the last term, a 2. And so if you take the product of these, 3y times 2y is 6y, and then you double that, do you get 12y? Yeah, so it fits that pattern. But again, with access to your calculators, you don't really need that pattern. And so in addition to these two special factor forms, they are going to have you solve equations. And the equation solving is kind of based on the same idea as these. If you have something that looks like this, if you recognize you have perfect squares at the front and the back, and if you take the product of these and double it, you do get this middle term. It allows you to identify this as x and 10, a binomial square. The sign between them has to be a negative because that's the sign of this middle term. And so if you set it this way and then solve for x, what value of x would give you a 0 in that factor? 10. And so there is your solution. It's pretty quick to solve it by hand. However, once again, you have a calculator. If you use the Algebra tab F2, number 1 solve, type your equation exactly as it appears.